Yo, what is going on, guys? Welcome back to another Universe Sandbox Squared video. Today we're going to be just checking out a little simulation to see what happens if we take Halley's Comet and make it collide with the Earth. Now, it's quite critical, as you guys know, to where it actually hits on Earth. If it hits on land, it creates a sulfur cloud. If it hits in the sea, it creates a tsunami. I'm pretty sure the shockwave, if it hits near sea but on land, would create a tsunami, but not as the same size as it would with a direct impact to the ocean. Now, it is quite hard to directly tell where the actual asteroid is going to hit, or the comet is going to hit. We can't really accurately bring it down to a place of any origin, but we can aim for an origin point on where we want it to collide with the planet. So I'm going to aim for the United States into Europe. That is quite a big gap, but I'm more aiming towards Europe to see what occurs. So let's go ahead, launch it, and let's get our tracking up and going. Sorry if there's any vibration in the bloody background. The state highway is literally behind this house. It's the worst place you could ever do YouTube. So let's obviously slow it down and see what happens. So it looks as if it might actually hit right in the middle of the Atlantic Ocean, maybe into the east coast of the United States. I'm pretty sure, yeah, the east coast of the United States, maybe into Canada, where these lights are showing. I feel like it might just hit on land. It looks as if that's land here as well. Maybe Greenland. And yeah, it's definitely going to hit into land, maybe into the lake here. Slow it down a bit further. Quite interesting. We're just going at a plane speed velocity of 10 kilometers an hour. Or is it 10? It's 10 kilometers a second, sorry. So more, quite a bit faster than 10 kilometers an hour. As you guys know, I think I could calculate that in my head, but it's 36,000 kilometers an hour. That's quite a bit of difference right there. So we are about to collide with the Earth. So a 10 kilometer a second velocity is quick in itself. Imagine light speed. Imagine light speed indeed. So it's definitely going to strike on land. I was actually expecting it to hit towards Europe, but I guess I got that wrong. Let's see what happens. Slow it down. Expecting for a big impact. Obviously, it would maybe wipe life on Earth out. Because sulfur cloud, it's obviously going to create that sulfur cloud that we were talking about. It's going to light up. Obviously, panic. Now, I'm thinking maybe a tsunami will occur since it's kind of near the ocean, but it's probably going to be a smaller one than what we would see with a direct impact. And we have impact. And let's get our timestamp up. And this is the year 2023. And let's see what happens. So we've got fragments coming off already, and it's only less than a minute after impact. Now we want to try and track the impact. And I expect maybe a few minutes, maybe a minute or two, maybe a few more for the shockwave to reach Europe. This is very fast traveling. We have fragments coming off the planet. Again, we're probably going to have quite a few secondary impacts. Usually the secondary impacts has more of an effect than the initial collision. Let's pause the simulation here and let's go take a look at some of these fragments and see the size. So I'm pretty sure Halley's Comet, if we can bring it up again, was 5.5 kilometers. So let's see if there's any bigger chunks that's bigger than Halley's Comet. That's 685 meters. That would be quite massive. We've got 791. So these are big chunks of land that's being thrown out. Impacts from these would be deadly in itself. That's only 9 meters, sorry. 9.4 meters. 500. What's the biggest in here? We got a 2. Oh no, that's a gas. So it's in under a kilometer for fragments. Some fragments that's coming up are gases, which is a bit of a pain, really, if we're looking at stats for these fragments. Yeah, so nothing over a kilometer by the looks of it, but these can additionally cause major impacts in themselves. Shockwave has reached down to North Carolina, nearly into Europe. It's just hit Greenland, I am expecting. Is it Greenland? Yep. Or no, it's Iceland. Greenland's in around here. I don't know my geography much today, do I? It's just hit Chicago. Additionally, as I was saying, I'd expect a tsunami to be pushed with this shockwave. The initial amount of energy that's been hitting the Earth is huge. So I would expect a tsunami to hit, especially if it was on a much more angular state instead of just straight into the planet. As you can see, heaps of secondary impacts have occurred and causing different shockwaves to go off. The shockwave has reached Europe, the United Kingdom, after about 3 to 4 minutes, so not long at all, and some secondary ones coming in as well. Fragments should collide with the Earth in around a area radius probably of 1,000 kilometers, if not more. Maybe if additionally they grab enough velocity and come out of the atmosphere quite a bit, it could cause secondary impacts around the whole planet. Here I'd expect all life in the United States to cease to exist due to this amount of energy. This is much more than a nuclear bomb. And as we can see, secondary impacts creates a huge crater. It creates a huge crater. That's bigger than what I expected, to be honest with you guys. And we are only minutes into the simulation still. And huge crater created down the east coast of the United States. I keep saying the west, that's the west. But additionally we also have a impact probably into the Yellowstone National Park and into different states and into maybe even, I can't really tell with the lighting, but it looks as if we've got some in around Europe and maybe Iceland as well. Additionally, these craters would cause a new, probably I'd say a new supervolcano or a massive amount of liquid magma to form, and that would cause a few eruptions in around the crater itself. And I'd say Yellowstone would actually erupt from a asteroid impact of this magnitude as well. So let's take a look at Earth's stats. It looks as if the surface temperature on Earth has not been altered at all, but definitely it would cause a huge temperature increase that is obviously not being shown on this simulation. And we can start to see how big the crater is that's been formed. Our one down in different states down here, I'm pretty sure that's Florida going into, I have no idea what the states of the United States are. But again, craters all over the place. It's actually altered, I'm pretty sure, our spin a bit, just a little bit, not very majorly, but I expect the temperatures to rise, as I said, tsunamis to probably hit Europe. I'd say the West, the Pacific would be alright for tsunamis, no tsunamis at the Pacific, but I'd say there would be a few more fragments that would hit in the likes of Australia and New Zealand, probably in the Pacific, maybe causing tsunamis there. The reason I'd say tsunamis are most likely to be in the Atlantic Ocean is mostly due to the secondary impacts that struck in the Atlantic Ocean itself. So let's go ahead and speed this simulation up a bit, and let's go have a look at what the Atlantic Ocean looks like. Obviously, we've got a crater there that has a heat zone which keeps water away from it. I'm expecting maybe after a few days or so, that crater would be cooling down, and that would create water to flow into it. Additionally, also we have an ice age in the United Kingdom that was completely off topic. That was just timing. So over time, the Earth, I'd say, would be able to survive this impact, but I'd say most of life on Earth would be dead, even though it doesn't look like it. I'd say the temperature would definitely increase of this impact. Now, since we've survived this impact, let's go ahead and let's turn up the velocity to 100 kilometers a second, which is, let me do some calculating, times 60, my math is really bad, it's 360,000 kilometers an hour, okay? So that is a full 10 times increase in velocity. Could have done that in my head, just times it by 10. And we're going to aim for Australia and New Zealand now. So we are going to have to slow down our simulation so we can get a realistic look. And this is only per second, and it's going really, really fast, as you can see. Obviously, probably go a bit faster than that. And it looks like we are definitely going to have a collision with Australia, or just down south of Australia. Let's see. It's actually going quite slow, isn't it? Yeah, it's definitely going to be a collision with Australia, or just around Australia, maybe into New Zealand. This is only seconds as well. 17 seconds per second. Very fast moving comet. Oh, interesting. It looks like it is definitely going to be on land Australia. Whoop. Yep. We got Queensland impacted. And let's see what happens after this impact. Obviously, heat spots coming up. Ooh, that's not good. You can definitely... Oh, yeah. Extreme heat coming off. Shockwaves. It looks as if we have less fragments. Oh, they're just shooting up further up in the air because there was much more velocity. But that would mean we're going to see... I think these might be pulled back down by the Earth's gravity, causing a much more distributed impact area. And this was quite close to land, so Pacific, even down into Tasman, New Zealand, would have a tsunami from this sulfur cloud, etc., etc. And hopefully we're right about these fragments. Maybe they're just going to shoot back into the air. Can we zero velocity? You know what? Just in case, let's say we took all these fragments and we zeroed the velocity. Zero velocity, so they come back down to Earth. Zero velocity, zero velocity, zero velocity, zero velocity, and zero velocity. Let's see what happens now. So it looks as if they're being pulled more towards the sun. That's my bad. Honestly, that is my bad. I was expecting them to more or less be dragged towards the Earth. Oh, wait. Nope. So it seems like that these fragments are definitely heading away from the Earth. And that kind of... that altered our spin quite a bit. I think, by the looks of it. Obviously, this would kill probably the entire Australian continent off, and even into New Zealand with extreme heat. I'm pretty sure by the looks of it, our spin has definitely been altered. Okay, let's do one last test with Halley's Comet, and let's see what would happen if we took it and struck the Earth at the speed of light. Our major test. And we have to slow it right down so we can see this actually happen, because look at it. This is only into milliseconds and it's going so quick. It's going very quick. So this is probably the maximum we could have, and it's legit millisecond per second, which shows how fast the simulation is going and how fast the objects are moving compared to what we had been testing. And it's going to strike in the ocean this time. And I'd expect definitely a big tsunami from this, if not one of the biggest tsunamis in the Earth's history. I mean, a light speed object striking the planet would be a gutting consequence. We can definitely already tell where it is going to strike. Earth's rotation is no match for this. Let's slow it down so we can get the best possible picture and the best possible simulation. Don't want it that slow though. And we have impact. And it shows no consequence because it was in the ocean. Well, that kind of sucked, didn't it? Oh wait, no, here it is. It was just because the simulation was so slow. And damn. There goes shockwave, tsunami, huge crater. Huge crater. That is definitely a big crater compared to what we had last time. Oh damn. It might stretch right into the South America. No. Yep. Looks like it will. And Earth's temperature definitely increase from this. Okay. Welp, the crater is filling the entire Pacific. And I'm pretty sure the Earth has died from that. Definitely a life-killing event. I'm pretty sure that's a bug. Temperature. Where's temperature? Temperature hasn't increased at all. Definitely a bug. Temperature would definitely increase. So that is definitely a bug in the game. I mean, the mantle showing. That would definitely have an increase on the temperature, surely. Surely. What impact has it had on the country's shapes? Definitely a tsunami would hit, unless, thinking about it, a tsunami wouldn't hit because the water evaporated so quickly. How's New Zealand? Oh, wow. Heat is definitely up there, you can tell, because not much water is present in between here, because usually definitely altered our spin even more. Okay, so that's what would happen if Halley's Comet struck at 3 different speeds. So guys, remember to subscribe for more content, leave a like on this video if you enjoyed it, and I'll see you guys in the next video.